Okay, what's the hybridization of each carbon atom in acetonitrile? So here is acetonitrile, CH3CN, and the way to figure out what the hybridization is around an atom, all you have to do is look at how many things are attached. In some textbooks, they call this the steric number, which is essentially, you can think of things as being either atoms or lone pairs. So around this carbon here, right here, and I don't want to confuse you, I'll just asterisk the carbon. The steric number is 4 because it has 4 things attached. And if the steric number is 4, or if there are 4 things attached, the hybridization is sp3. So let's look at this carbon. Different color here. So what's the steric number around this carbon? Well, how many things are attached to this one? There's this carbon, and then there's this nitrogen. So it's not about how many bonds there are, how many electrons, it's just how many things are attached. And so since there are only 2 things attached, the hybridization is sp. It's that simple. So let's look at something like this, where you're looking at, I don't know, let's look at dichloroethylene. So what about the hybridization around each one of these carbon atoms? Well, this carbon has 1, 2, 3 things attached, so it is sp2. And likewise, this carbon atom right here has 1, 2, 3. So this one is also sp2. How many different things are attached to a particular atom tells you its hybridization, and by the way, it tells you its geometry. So sp3, the geometry is tetrahedral. sp, the geometry is linear. And sp2, it's trigonal planar. And same with that sp2 carbon. Both of these are trigonal planar. And actually, that has implications for the geometry of the entire molecule. If both of these atoms are trigonal planar, then we know, and I'll just draw this in sort of a perspective, we know that the whole molecule must be planar to accommodate 2 trigonal planar atoms right next to each other. And this makes sense if you think of the overlap, the p orbital of this one overlapping with the p orbital of that one. And that's why we have sp2 hybridization, because the other 2 p orbitals and the s orbital hybridize to give, and I'll write these in different colors, 3 new sp3 orbitals. And each one of these lobes here has a little lobe on the other side. This lobe has a little lobe on the other side there. And this lobe has a little lobe in the back. And then that overlap between these 2 sp2 orbitals gives you the sigma bond in the middle there. And then it's the overlap between the s orbitals of the hydrogen and the sp2 orbitals here and here. This and this, those are also sigma bonds. And then, of course, this here is a pi bond that's above and below the plane.